So welcome to this video that I've titled, What is a Computer Network? In this video, we're going to cover several things. We're going to cover the parts of a common computer network. We're going to talk about what is a computer network in case you don't know, and why would you use one, and some common vocabulary, and like I said, why do we need computer networks in the first place? So let's start with the basic, high-level, fundamental question that you need to answer, which is, what is a computer network? Now, chances are you've probably been working on computer networks of some size or shape for years, maybe decades if you're as old and ancient as I am. But you may have never used that term before and don't really know what a network is. Well, a network is really simple. At its basic core, a network is two or more devices that need to share information. And those two devices, in order to share that information, well, they need to be connected to some common media like a cable, in which they will share that information, most likely electrically, using electrical signals or pulses. Same type of electricity that comes out of your wall jack when you plug something in. Now, of course, networks these days can also be wireless, and I'm going to talk about that in just a moment. So, in the old days, let's go back to the not sure how far we'd have to go back here. 1950, okay, 1940, 1950, 1960. If two people were working on their own individual computers and they wanted to share information, how did they do that? Well, if you weren't born back then, you probably don't know. What you did was you had something called a floppy disk, which depending on the size could be like this big or maybe about this big, but you plugged a floppy disk into your computer, you copied your information onto it, and then you walked it over to the other person's desk, handed them the floppy disk. Hopefully they paid you a handsome tip. They put the floppy disk into their computer, and voila, you had just networked with them. There was actually a term for this which was called sneaker net, because you had to use your sneakers to walk over the person and give them your data. Clearly, not a very scalable way of networking. So networks came out with this idea of, hey, let's connect everything initially with a cable. Have all the devices connected to a cable, and then by using electrical signals and impulses, we can just digitally send our information back and forth between the devices. So that's like what we have right here. Here we have two departments, Department A and Department B. They're both on their own separate networks, and they can talk to each other because they're connected to the same wire. Now, what if it turns out that we say, hey, I actually want Department A and Department B to be able to exchange information between the departments? Well, certainly I could take this wire and connect it, and now everybody's connected to one big wire. And in original networks, that was the way it worked. But here was the downside to this. When original networks first came out, this wire was a shared medium, which meant that only one person could talk at a time. It's kind of like you're in a room with a bunch of people, right? If everybody's talking at the same time, kind of hard to make out any conversations going on. So everybody has to be polite. Only one person can talk at a time while everybody else has to be quiet. Well, that's fine if, let's say, you're in a room with 4, 5, or 6 people. Everybody can sort of take turns. But what happens when you get in a room of like 100 people or 1,000 people? Good luck getting your turn to talk, because everybody's going to have something they want to say, and everybody's going to want to jump into that quiet space in order to say something. Same thing here. In the original networks, as the wire got longer and longer and longer, there were more devices that were wanting to talk. And so there ended up being problems where devices would say, hey, let me tell, and then all of a sudden somebody else is talking at the same time as you, which was called a collision. So they had to stop and retry again. So connecting everything to the same wire was okay as long as there were only a few devices on that wire, but it was not a scalable situation. So networks evolved, and somebody came up with the bright idea of, hey, let's connect a networking device to these two wires that will keep the wires separate. All right, so let's take a look at this. So for example, why don't we do this? Instead of having everybody connected to the same general cable, let's give each person their own unique cable, their own independent cable into this networking device called a bridge. Nowadays we call it a switch. So those dashed red lines here represent individual cables that each person's computer or laptop is connecting up to the switch. Now the idea with this is much better, because each one of these people could talk whenever they wanted to. They could send data on their own individual wire whenever they wanted to, and the switch would collect all this information. Now, if all the information came in at the same time, like let's say 2 or 3 people talk simultaneously, The switch was okay with that. It had the intelligence to take in all this information, and then it had even more intelligence to say, oh, this message here came from Bob, it's going to Sally. Sally lives on this wire over here, so I'll convey Bob's message to Sally over here. So we didn't have to worry about, hey, when I'm talking, like in a room, everybody has to be quiet because everybody's going to hear me. Now maybe I'm just talking to Sally, who's in the room with me, but in that environment, everybody in the room is going to hear you, right? You can't really have a private conversation between you and Sally because John and Pablo are also in the same room with you. That was like the original way where everybody was on one wire. When one person talked, everybody heard it, even if John was just trying to communicate to Sally. Here, with a network switch or bridge introduced, everybody has their own wire, and so now the switch or bridge in the middle is collecting all the information and playing it out on the individual wires where it needs to go. So this is a way of expanding our network and connecting multiple departments together without worrying about that whole thing of only one person can talk at a time. Now this is your basic wired networking here. Then a few years later, wireless networking was introduced. So now we have the idea of, hey, what I'm transmitting into is the air. I'm using radio frequencies, like the exact same radio frequencies that come to your car radio when you're driving around, right? And so using radio frequencies, I can transmit my data into the air, and that data is received by a special device called an access point. We'll look at that in a little bit. Okay, it also has a radio, it also has antennas on it. So your data is going to him, and then that device can put your data onto the wire. So these two people here could talk to each other wirelessly by sending their information through the access point. Maybe they're connected to the same access point, maybe not. But now if I have these people down here in this department and they want to talk to any of the people up here in the wire department, clearly I have to have a connection between them. Okay, so once again, I could do this. I could connect one switch to the other switch, just connect a wire between them. I could certainly do that. But then some people said, hey, we should have some way of segmenting or dividing our networks logically. And so, Sally, when you're connected to the network, your device, your laptop or PC will not only know that it's connected to a wire or connected to the wireless network, it will also know what part of the network you're on. So Sally's device will know, hey, I'm on the payroll network or the engineering network. It's a little bit more complicated than that, but that's the essence of it. And so the idea was, if we can do that, if we can group users into certain sections of the network, like payrolls over here and all the devices in that section know what group they're in, now we can introduce some sort of like security. We could say, all right, it's okay for payroll to talk to human resources and exchange data, but we don't want payroll and marketing talking to each other. Now, if everybody was just in one big network with an interconnection of wires and access points and stuff, they would be kind of hard to implement that kind of security. But people said, hey, let's divide networks into groups, and then we'll have another device that knows where all those groups are, and when data comes in from payroll going to marketing, it will have the intelligence to know, oh, marketing is over here, or engineering is over here, and that device could also implement some security if we want to. So that device is what we call a router, and we see that right here. So now the router is connecting up those two switches, but now the router has the intelligence to know that, okay, department A and B are on this side of me, and the wireless users are over here, and I can send their data back and forth because I know where everybody lives. Okay, so this was all great. Okay, now back once again in the early days of networking, the information that you had was locally stored on your laptop or PC, and the information you were trying to get from Sally was locally stored on her laptop or PC. Well, people started realizing, hey, I've got 1,000 employees in my company, and it's getting kind of complicated to know where is the data that I want? Where's that file? Where's that image or picture I'm trying to get digitally? Is it on Sally's, or is it on John's, or is it on Paco's laptop? Where is it? So people said, hey, let's take all our data and store it in a central place. We'll take a certain section of our network, we'll make it very secure. You can only get in there with a badge just behind a locked door, with a policeman with a machine gun and a couple machetes standing right there to protect it from getting in there. And that's where all data is going to be stored. So the users will have to get to that place over the network. They'll have to send a request over the network to that place to retrieve whatever data they want. And that was called funny enough, our data center, the center of our data. That's where we're going to store it. So you can see here, these pictures that we see are just stacks of what we call servers, which is basically a computer, like the computer you're working on. It's just a very high-powered computer with a lot more brain power than your computer has and a lot more information to store a lot more stuff. So we have a data center here. We connect it to the network. And so this is your common network here. And then people said, hey, this is all well and good if the only data I want to push somewhere or retrieve somewhere is within my company. But now this great thing called the internet came up, and I want to get data from John's data center who's in another state, or Sally's data center who's in another country or continent. So we needed the internet to do that. So we need a connection to the internet. And what is the internet? The internet is just an interconnection of networks. So the internet is just billions of networks all connected together. The network at your house is part of the internet. The network at your company is another network connected to the internet. So originally the network, a lot of people called it the World Wide Web. You might remember that, WWW, the World Wide Web, because they thought of it as like the spider web of interconnected networks all connected together like in a spider's web. They called it the World Wide Web. Now we don't really call it that anymore. Now it's just called the internet, but our network also needed a connection to that. And so we would have some sort of cable or wire leading out to a company that would provide service called an internet service provider. You probably know them as Time Warner Cable or AT&T or Sprint or Comcast. Those are companies that you pay a monthly bill to. You connect over a cable to them, and then they connect you to all these other billions of networks around the world. They are your internet service provider. All right, so just some common vocabulary here in the terms of networking. First of all, LANs and WANs. You'll find as you start going down the road of networking that there's about 5 gazillion acronyms you have to memorize, and they never seem to stop creating new ones. So LAN stands for local area network. WAN is wide area network. What's the difference? So a local area network is a network that's locally in your surroundings, okay? It's, for example, in the building you're in, like that picture I just showed. Let's just go back to this for a second. All right, so everything inside this green sort of oblong shape here is a LAN. So all of this is our local area network. It's fairly confined in geographic scope. So one end of a LAN going to the other end of a LAN typically is not very far in distance. You know, maybe a few hundred feet, maybe certainly less than a mile, like a quarter of a mile at the most. So that's a local area network. And some of the characteristics of a local area network are, if you're the network administrator who's in charge of that local area network, you're in charge of all of it. You're in charge of figuring out what cables need to be there and laying those cables down. You're in charge of figuring out what networking equipment like routers and bridges and switches we just talked about, what you need and installing those and placing them. So that entire network is your baby. It's completely under your control. That's a characteristic of a LAN. Now, as a WAN though, a WAN is when you want to connect two networks together that are far apart, and you don't have the resources or the money to actually string a cable between those two networks. For example, maybe you have a network in your office in Boise, Idaho, and another network in your office in Miami, Florida. Well, between Boise and Miami, you can't string a cable between those. Now, maybe if you were Donald Trump and you had billions of dollars, you actually really could afford that cable. But even if you could buy the cable, you're not going to be able to get the government permits to dig a trench 3,000 miles from Boise to Miami. It's just not going to happen. Fortunately for us, there are companies out there like AT&T, like Time Warner Cable that have already dug those trenches and laid the cables, or laid the cables across in conjunction with telephone lines. So the connections, the physical cables do exist interspersing the country and the continents, but they're not yours. They're owned by these other companies. So in order to connect to those companies and use those cables, we use a wide area network, and that is what a WAN is. So wide area network is a network that's expanding a vast distance. It's beyond your control. You have to rent the services of a company and rent their WAN. They're in charge of setting it up. They're in charge of maintaining it, and you're just paying for the right to transport your data across that WAN. And there's lots of different kinds of WANs as well. A node or a host. So node and host is basically the same type of thing. It's basically any device that's connected to the network is called a node. So for example, a node could be your laptop, your PC, it could be your smartphone, your tablet. A node is also the router, the switch, the bridge, the access point. We call all of those things nodes. Now, sort of what makes a distinction between a node and a host is that a host is a node. It's one of the many types of nodes, but a host is a specific node that's responsible for creating data and putting it on the network. Or it's the endpoint of data. In other words, data goes through the network and terminates at a host. So for example, we would call your laptop or PC a host because a laptop or PC is what's creating the request for data, or it's pushing the data onto the network. And maybe at the other end of the network, another laptop or PC or a server is receiving that data. So those would be hosts. We wouldn't typically call a router or a switch or a bridge what we typically call network infrastructure devices. Infrastructure meaning these are the components that build the network and present the network to us. We wouldn't typically call those hosts because they're just transporting data back and forth. We don't normally think of them as originating and creating data or data terminating on a router, a switch, or an access point. Now it certainly can, but in this terminology here, that's sort of the distinction between node and host. We also have local versus remote resources. This is basically a distinction of the data that you're trying to get. Is it locally stored on your own laptop or PC? Okay, so if you completely disconnected from any network at all, would you still have access to that data? If the answer is yes, that's a local resource. If the answer is no, the only way I can get to that data is if I'm connected to a network somehow. For example, Facebook. You can't get to the resources on Facebook unless you're connected to a network. So the resources on Facebook, all the images it can give you, the text it can give you, those would be considered remote resources. And we've already talked about what the internet is. I don't think we need to go into that. So hopefully this point's becoming a little bit more clear as to why we need computer networks. It's number one, to avoid sneakernet, right? Of course, sneakernet's good for exercise. If I have to change data with somebody in Idaho, what better exercise than to walk 3,000 miles over their PC and hand them a floppy disk, but not really all that scalable. So it helps us to exchange data between devices, and we don't have to get out of our chair. We can get nice and lazy and fat and not even worry about it. So networks basically allow us to share things between devices. We can share files. We can share programs, right? Maybe I've got a program that's used to draw graphics, or I have a program that's used to create music. And over the network, I can send you that program so you can install it on your device. Or we can share resources. For example, a network-based printer would be a resource. Okay, I could say, hey, you know, I don't need to send every single employee in my office their own unique printer, as much as they probably like that. I can say, hey, there's a printer over here in the corner. Let me give you the access instructions so you can reach it over the network. That would be considered a resource that you can reach over the network. So that concludes this particular video. I hope you learned a lot, and thank you so much for watching.